Hello everyone. So in the first video we saw how to specify and run a simple CCSL file, and this file was this one with two clocks and a simple preset relation in between the two clocks. When we run the simulations, actually TimeSquare created some trace folders when he stores the result of the simulation. So for example, in the first one we didn't ask for any VCD generation, but we had a trace model as well as a CCSL relation model and the specification which was used for that. And in the second simulation folder we got the first file and the VCD, which is the one which is just open here. Actually the trace model is storing all the ticks of the different clocks, and the CCSL relation model is storing the different relation between the instance of the clocks. So if you need to replay something, you can use this file, and if you want to visualize it again, you can reopen the VCD, and this can be used for analysis, for instance. Another thing which is possible with the CCSL file is to ask TimeSquare to show the clock graph. The clock graph just shows the relation in between the clocks. So here we just have one relation, which is a preset relation, and this will be used later for analysis. Okay, here this is a simple preset relation which is offered in the kernel library. If you want to know more about the kind of relation we have in the kernel and in the CCSL library we provide with TimeSquare, you can have a look on the website. In the example section we have two subsections, which are kernel relation here and kernel expression here, and for each of these items you have the different relation expression provided. For example, the preset we just used is here is a simple test and the result of the test. Of course you can choose the other one, like let's say subclock. So please have a look for some things you're looking for. We're just gonna see an expression, because an expression is creating a new clock. For example, the weight expression here. By using this you can have a new expression which is based on some clocks and some other kind of parameters, here an integer. And we will see that on a real demo. Okay. So we will create an expression. I've got several of them which are provided here. Let's say I'm going to use a periodic expression. So once again it gives me the skeleton of the expression, and this is red because the result of an expression is a clock. So I will name it, for example, C1 periodic 5. And I have to set the parameters, so the base clock is C1. The periodic period is 5, and the offset, let's say it's 1. Here I use 5 and 1, which are actually provided in the CCSL library. If you just navigate like in any Java-like wait, I make some room, with control and click, you're now in the library, and you can see that we define just few integers to ease the specification. Of course, if you're not happy with that, you can create your own integer and give some value. Okay. So I create a new clock which is periodic on C1 of period 5 and offset 1, and I rerun the simulation. So I had to add again the new clock in the VCD specification. Okay, if I look here, I just have C1 and C2, so I re-add the new one. Okay, let's run. This is the new simulation. So I've got C1. After an offset of 1, I've got C1 periodic, and 1, 2, 3, 4, 5. Every 5 you got a new C1 periodic 5. If I'm looking at the constraint view, I've got many relations here. It's because periodic is not a kernel relation. It's made up with several kernel relations and encapsulated in a library. If you want to see this relation, just go in this clock, just go in the ordering part and add all the internal clocks of periodic. Okay, I will not detail it here, but just know that if you choose all the relations here, you will understand that they are all linked together. In this case, the white arrow are precedes relation between instants, and the red one are coincidence between instants. It means that they are occurring at the same time. Okay, and if we go back to O5, you can see that the periodic is green. It means that it's not a kernel relation like this one. It's in the CCSL library, while the first one was in the kernel library. If you want to know how this is done, you can once again navigate through it, and you will have all the CCSL library you can see. It's kind of difficult to make some new relation or expression, and I will detail that in another video. Okay, so here you got your new specification. You can generate once again the VCD, and of course you can ask for the new clock graph, and the new clock graph is here. It's a bit more complex than the previous one, and once again the goal here is not really to visualize it, it's to be able to make some analysis on it. And finally, because we made a new simulation, you got your new results of the simulation here, and the specification which has been used for the simulation. Thank you.